All right, so lesson 44 is on integrating exponential and logarithmic functions. So this starts out pretty simple. I don't think you're going to have trouble with these first four. So if I'm integrating e to the x, is it a surprise that it's e to the x? Right, so if I integrate e to the x, it's itself, right? No big deal, just like derivatives. But obviously we're going to make it a little bit harder than, just e to the x. So if I have e to the negative 2x, okay, we're going to make u the negative 2x. du is going to be negative 2 dx. So we're going to have a negative 1/2 du equals dx. So we're doing a U-substitution. So when I change this, I'm going to have the negative 1/2 out front, and the du, that's replacing our dx. And then our e to the negative 2x is e to the u, right? So basically I've replaced everything. That was a u, the dx was replaced by negative 1/2 du, and so on. All right, but I told you last time that when we have numbers, like if it's a definite integral, so I have 0 and 4, I want to change those as well. I want to change those from x values to u values. So if I have u of 4, I'm replacing 4 for x into the u equation. So I have u equals negative 2 times 4, so I get negative 8. And u of 0 is going to be 0. So my limits of integration now change, and they go from, instead of 0 to 4, they go from 0 to negative 8. Which might bother some of you, seeing the 0 to negative 8. If it does, just flip it and make it negative, right? So that negative 1/2 can become positive 1/2 instead, and it goes from negative 8 to 0. It doesn't matter. I usually just stay with it. All right, so if I'm integrating e to the u, it is itself, it's e to the u. So I have a negative 1/2 e to the u integrated from 0 to negative 8. Okay, let me go down here. So I'm going to get a negative 1/2. I usually kind of pull that number out to the front. So I have e to the negative 8 minus e to the 0. Okay, and I'm going to simplify a little bit. So I'm going to have negative 1/2, and e to the negative 8 is 1 over e to the 8. E to the 0 is 1. Okay, and you can leave your answer like that for me. Like, I'm fine with this. But just know that on the AP test, they don't typically leave it like that. What they do is they combine as much as possible. The least amount of typing possible, right? So they would get common denominators. So if you're combining these two terms right here, what would it be when you combine them? E to the, well, not e to the 8, hang on. 1 minus e to the 8 all over e to the 8. Do you guys see that? So you're going to have a negative 1/2, and you're going to have 1 minus e to the 8 all over e to the 8. And then they would distribute this negative 1 to the top, kind of do parentheses, and distribute the 2, multiplied by 2 on the bottom. So we'd have e to the 8 minus 1, right? If I've multiplied by negative 1, I'm switching the sign on both of them, all over 2 e to the 8. That would be the other way that they would write it. Does that make sense? Okay, so number 2. So think about what your u would be. What do we think? Do I need to call on you guys? Eric, what's the u? You guys had this long weekend and you're just dragging from that, aren't you? Man, right after lunch too. It's rough. Yes, it should be 4 plus e to the x. It's the inside part. Remember, just as if you're taking the derivative, it's what would involve a chain. So it's going to be 4 plus e to the x. Its derivative is e to the x dx. So that's nice for us because e to the x dx, that's what's left when I replace this part with u to the 5th. Okay, so when I'm writing my new integral, I have u to the 5th du. That's it. So if I integrate that, I know how to do that. Antiderivative is 1/6 u to the 6th plus c. So your final answer is 1/6 times 4 plus e to the x raised to the 6th plus c. That's it. And you can check if you take the derivative, the 1/6 and 6 cancel. You have 4 plus e to the x to the 5th times the chain e to the x plus 0, right? That's what we had in the integral. Does that make sense? All right, so let's try a couple more with the e's. Any ideas on what to make u? I heard someone say it, square root of x, yep. du, we just had this on your derivatives drill. 1 over 2 root x, exactly. Or you could write it as 1/2 x to the negative 1/2. So we're really close here. Like this part is e to the u. Oops, I moved it. But then we still have a 1 over root x dx, right? So I have an extra 2 here. So I'm going to multiply by 2 on the other side. It's going to have 2 du equals 1 over root x dx. So that way everything that's left is going to be replaced. It's going to be replaced by 2 du. So when we change it around, we get e to the u, and then we have 2 and a du. So 2 integral of e to the u du. So when we integrate, we get same thing, 2 e to the u plus c. So we get 2 e to the square root of x plus c, and that's it. And again, you can always take the derivative and check. We're good. U for number 4. Yep, sine of x. You guys are getting good now. You're waking up. Derivative of sine is cosine. Yep. So that's nice for us because that's what we want. We want cosine of x dx, right? So as I replace, I get e to the u du, which gives us e to the u plus c. So our answer is e to the sine of x plus c. Done. Okay, feeling good about those? Pretty easy. All right, now it's been a while since we've talked about things like number 5, but it says find the particular solution. Okay, when you see something like that that says find the particular solution, basically you're going to be given either f prime or f double prime, and you have to go backwards. You have to find the antiderivative until you get to f of x. Okay, so we're solving for f of x with this. So in this case, we have f double prime. So we know that f double prime is equal to 1/2 and then times e to the x plus e to the negative x. So I'm going to go ahead and distribute that 1/2. So I'm going to have 1/2 e to the x plus 1/2 e to the negative x. Okay? And I'm going to take the antiderivative to get the next thing. I want to find what f prime is equal to. Okay, so I'm finding the antiderivative. I'm integrating. So when I do that, what do I get? How about the 1/2 e to the x? What's its antiderivative? It's not hard. 1/2 e to the x, it's itself, right? Because the integral of e to the x is itself, e to the x. Okay, but the next one's a little bit tricky. So if I have 1/2 e to the negative x, and I integrate that, it's like a U-substitution. It's like letting u equal negative x. You gain a -1, right? So it's going to be negative 1/2 e to the negative x. Okay, but we always need a plus c. So we're going to do plus our constant. And then these, the f of 0 and f prime of 0, these are what we call initial conditions. Okay, so that's why it said that satisfies the initial conditions. So that allows you to solve for any c value. So it's saying when I plug in 0 into the f prime equation, I should get an output of 0. Okay, that's what it was saying. It was saying that f prime of 0 is equal to 0. So we simplify. We're like, okay, 1/2 e to the 0 is 1, minus a 1/2 times 0, plus c. All of that has to be 0. So what's c? 0. Yep. So that means that our f prime is really 1/2 e to the x minus 1/2 e to the negative x plus 0. Okay, the c was 0. And we go again, because we want to find f of x. So we do the antiderivative again. So when we do that, I get f of x equals, again, 1/2 e to the x. That part's the same. That part will always be the same, right? And then I have, what do I need? Plus now, right? Plus 1/2 e to the negative x plus, we can't say c because we already used c. So you could be fancy and you could call this like C1, 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 and then you could do C2. Okay, I just use D. Just mix it up. The only one I feel weird about using is F. All right, so I'm going to do plus C, or plus D after I just told you. And then now we're using f of 0 is equal to 1. So I'm saying when I plug in 0 for x, I'm going to get 1 for the y value. So I get 1/2 plus 1/2 plus d equals 1. Yeah, did you guys see d is equal to 0? That was convenient. Wasn't that nice of me? So your final answer is f of x equals, yeah, so Audrey's noticing, it's the same thing as what? The very first one, right? F double prime. So this one's kind of a cool function because it iterates, it repeats, okay? So basically after every two derivatives you take, so like f of x is the same as f double prime, which is going to be the same as f to the, like the fourth derivative, and then the sixth derivative, and the eighth. Does that make sense? It's always going to go back and forth between those two derivatives that we wrote. Kind of cool. All right, so moving on. So we talked about this a little bit. So we said that if we're integrating 1 to the x, obviously it should be something with natural log, right? Because natural log of x, if I take its derivative, it's 1 over x. Okay, but it's a little bit tricky. You have to put an absolute value. Okay, so don't forget the absolute value. So it should really be the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. And basically, it has to do with the picture. So we've talked about how integrals are related to areas. So if I wanted to integrate 1 over x from -3 to 2, right, that's this picture, -3, sorry, to -2, right? It's this little bit right here, which will be a negative integral. I'll get a negative answer out. Do you guys see? But there's definitely some number associated with it. And it actually ends up being symmetric to +2 to 3. It ends up being like kind of the same thing there. Do you guys see? It's the same thing, but it's the opposite of it. It's negative. So what happens is if you didn't have natural log of the absolute value of x and instead did natural log of x, you would get undefined, because this would be the natural log of -2 minus the natural log of -3. And try as you might, you can't do the natural log of a negative number, right? So we're stuck. But we know that there's a number associated with it. There has to be an answer. So that's why you have to do absolute values. Okay, so you have to put the absolute values in right here. So then it's really natural log of the absolute value of -2, natural log of the absolute value of -3. So it ends up being natural log of 2 minus natural log of 3, which if you put it into your calculator, that is a negative number. Okay? Do you see how it's the opposite of natural log of 3 minus natural log of 2? Right? That's why it's like symmetric like that. All right, so do not forget your absolute values. You will get counted off for that on your AP test. Okay? So it says evaluate the following indefinite integrals. So we have the integral of x over x squared plus 1 dx. Okay, kind of a preview of what we're getting ready to do next time. What if I had that and there wasn't an x on top, instead it was a 1? Nick said it, what is it? Arctangent. Yeah, it's tangent, the inverse tangent. Do you guys remember arctangent? Right, when you take the derivative of that, that's how you get 1 over 1 plus x squared. Right, that's exactly what it is. Okay, so the difficult thing with calculus is just like with derivatives, sometimes you guys don't know the easiest way to do it. Like, should I bring the monomial in? Should I use quotient rule? Should I use chain rule? Like, what's the easiest way? Same thing with integrals. You guys are going to learn lots and lots of integration techniques. And it's going to be frustrating because you're going to think it's a U-substitution and maybe it's something like that, where it's arctan. Does that make sense? All right, now this one is a U-substitution though. So what am I going to let my U be? Guesses?
X.
Nope, you never let U be x, because then that's just replacing u's and x's, right? So we don't want to do that. It's the x squared plus 1. So we get 2x dx. So on the bottom here I have my u, and then my x dx still needs to be replaced. So really I'm going to have a 1/2 du that's replacing the x dx. So I'm going to rewrite it as 1/2 the integral of 1 over u du. Okay? And I can integrate that. I know if I have 1 over u, think about it. If it's u to the -1, if you try to add 1 to the power, that's when it's like red flag, like u to the 0, 1 over 0. Right? This is the natural log. So it's 1/2 natural log of the absolute value of u plus c. So it's going to be 1/2 natural log of the absolute value of x squared plus 1 plus c. But the AP test, you know how I said they would count you off if you didn't have the absolute values? They totally would. Like right here in the integration step, if you did not put the absolute value, you would not get that point. But your AP test will write their final answer like this. Yeah, Alex?
So if you have the absolute value in the answer, but you don't have it in the steps, they count it off.
Yeah, you have to show steps on the AP test. If you don't show the steps, you're only going to get 1 out of 9 points. Isn't that sad? You have to show your steps. They have to grade something. All right, so tell me why. With the AP test, why would they write it like that? Why is that acceptable? Yeah, what do you think?
It's x squared, so
Exactly. X squared plus 1, that's positive regardless. It doesn't matter what you're plugging in for x. It's always positive anyway. So they would actually have that if it was on the multiple choice section, which is confusing for students because they like look for the absolute value because they know that like a lot of times they'll leave that off as an answer and you're like, oh, it can't be that one. There's no absolute value. But in this case, they could leave it off. All right, so number 2. Is it a U-substitution problem? No. Have I trained you enough to realize that when you have something on the denominator like that, that's a monomial, just one term, what do we do with it? All right, bring it into both pieces, right? So we rewrite. So we're going to do 1 to 2, and we're going to have 4 over r cubed plus 1 over r dr, which the 4 over r cubed, I'm going to write that as 4r to the negative 3, so you can, it's easier to integrate. But I'm going to leave the 1 over r, because that part's the natural log 1, right? So when we integrate, we're going to get r to the negative 2. We add 1 to the power. We have 1 over that new power, but we still have that 4 as well. So we have that. So 4 times negative 1/2, so really negative 2 r to the negative 2. And then we have plus natural log of the absolute value of r. Don't forget your absolute value. Normally we'd have a plus c, but this one's different because it's actually a definite integral. So we go from 1 to 2. So we have negative 2 over r squared plus natural log of the absolute value of r. I'm going to rewrite so I can plug in the numbers easier. Okay, so when I plug in a 2, I get negative 2 over 4 plus natural log of the absolute value of 2, which is really just natural log of 2, right? Minus negative 2 over 1 plus the natural log of the absolute value of 1. Do you guys know the natural log of 1 without using your calculator? No?
0.
It's 0, right? Because natural log is really log base e. So when you have log base e of 1 equals something, what you're saying is e raised to some power gives you 1, right? Well, that power would have to be 0. So all of this goes to 0. So I have negative 2/4, which is negative 1/2, right? Plus natural log of, I'm just going to write 2, plus 2. So your final answer is 1.5, so 3 over 2 plus natural log of 2. Okay, and they might do some fancy things to make that look differently, but for the most part, it's like that. On that last one, what do you think they might do with that 1/2?
Bring it in.
What do you mean by bring it in? What it would be?
Like you could multiply everything by 2 or something.
No. It's a square root, right? It's square root of x squared plus 1. They could do that. So look for things like that as well, right? Powers can go up, or powers can go to the front, basically. So they can go back. Confusing. They will use all of those log rules. You need to know all of the log rules. All right, so the integral of sine of x, cosine of x. This is me asking you, how do I integrate tangent of x? All right, we don't know how to integrate tangent right now. There's nothing that I take the derivative of, well, not anything that you know from a derivative drill or anything. Like, what do you take the derivative of to get tangent out? We know how to take the derivative of tangent and get secant squared, but we don't know, like, how to go the opposite way. Does that make sense? All right, and all it is a U-substitution. So whenever I'm trying to integrate tangent, I just do a really quick U-substitution. So I'm going to let u be the denominator, cosine of x. And du is going to be the derivative of cosine, which is negative sine of x. I don't know why I put the dx up there. Are you like, what is she doing? There we go. So as we replace, this part becomes like 1 over u, right? And then the sine of x dx is replaced by negative du. So I'm going to have a negative and a du. So as I integrate, I get negative natural log of the absolute value of u plus c. So we get negative natural log of cosine of x plus c. And this is the way that I have memorized the integral of tangent, the antiderivative of tangent. Okay, but if you notice in the little box, there's a different way. All right, how did they get the secant x? No. Yeah, this negative out front, right? It's like a -1, is going to go up as a power on cosine. Now, it's not cosine to the negative, like it's not inverse cosine, I guess I should say. It is cosine raised to the -1, which means 1 over cosine. So that's how they get natural log of secant of x. So, I mean, different books will write different things. Some of them write natural log of the absolute value of secant of x. Some of them write negative natural log of absolute value of cosine of x. It doesn't matter which one you memorize. Okay, I wouldn't even really memorize it. So I even wrote that there. Don't memorize this. Just remember how we computed it. I would just do a quick U-substitution. Because what if I asked you the integral of cotangent? Well, then it's the same process, right? It's cosine over sine. So let u be your sine and then go from there. Okay, so it's a little bit different. All right, so some of you guys are really good at some of the things we've done so far. And we talked about this before we started this lesson. If I had e to the 9x dx, some of you guys can do this without a U-substitution. Okay, what would it be? 1/9 e to the 9x plus c. Don't forget your plus c. All right, what if I had the integral of sine of 8x? Are you guys debating on cosine or negative cosine? So it's negative cosine of 8x, but then what do you have to multiply by? A 1/8, right? So it's actually going to be negative 1/8 cosine of 8x plus c. Does that make sense? So basically, if you ever have a U-substitution, so think of the chain rule, how it's related to the chain rule. If you ever have a U-substitution where if you had taken a derivative, the chain would have just been a number, like a ×2 or a ×3, something like that. Then if you want to undo it with integration, you just do 1 over. Does that make sense? So if it's ever just a number, you can do that. But you cannot do that for things like e to the x squared. So caution, this is not e to the x squared times 1 over 2x. It doesn't work that way. Okay, it's only if it's a number. Does that make sense? I don't know what you're saying. All right, integration formula for a to the x. So this is what it's going to be. So if I had, let's just think about the normal, 7 to the x. You just have this on your derivatives drill. Its derivative is 7 to the x times natural log of 7. Do you guys agree? This is a constant. It's a number. Natural log of 7 is a number. So if we're undoing it with the integral, we put it on the denominator. Does that make sense? So it's a to the x times 1 over natural log of a. It's like undoing the natural log of a. Okay, so that's why I always say you have to, you really have to know your derivatives, because now when we do the antiderivatives, it's going to be really confusing if you don't know them. So you should be memorizing these. All right, 3 to the x. So if I integrate 3 to the x, it's going to be 3 to the x over natural log of 3. You got it? We're going from 2 to 5. So we plug in. So we have 3 to the 5th over natural log of 3 minus 3 to the 2nd over natural log of 3. Does anybody know what 3 to the 5th is? 3 to the 5th? It's always a Sycamore student that blurts this out. I'm surprised. Audrey, I'm sad. It is 243. So it's all over natural log of 3. Yeah, that's right. Maggie, too. Several of you. So I get 243 over natural log of 3 minus 9 over natural log of 3, which becomes, what is it, 235? No, 234 over natural log of 3. All right, and the last example, I'm going to do it real quick. I still have time. I have 4 minutes. They're just letting out early. All right, there we go. So u is equal to 3 to the x, or 3 of, dang it, u is equal to 3x. du is equal to 3 dx. So we gain a 1/3. Now, some of you guys might have been able to do this without doing the U-substitution. That's fine. You would have 2 to the 3x natural log of, or over natural log of 2 times a 1/3. All right, but I'm going to do the U-substitution. So I'm going to change my x values to u values. So if I plug in 2, I get 6. If I plug in 1, I get 3. So my new problem is 2 raised to the u with a 1/3 and a du. And my u values, instead of being 1 and 2, like the x's were, they're now 3 and 6. And then I go for it. So I'm going to have a 1/3 times 2 to the u over natural log of 2, going from 3 to 6. So I have 2 to the 6th all over 3 natural log of 2, minus 2 to the 3 all over 3 natural log of 2. And you guys know those numbers? 2 to the 6th is 64 minus 8 all over 3 natural log of 2, 56 all over 3 natural log of 2. That's our answer. Okay? Would you be able to find the exact answer? Exact answers are important sometimes. All right. Let me close this out.